Good morning, children. How are you? Yes, I am also fine. Okay. So now we had discussed factor theorem. Sorry, remainder theorem. Now today we'll discuss about factor theorem. Factor means a polynomial, an algebraic expression which will divide that polynomial completely. Then both are that polynomial is the factor of that bigger polynomial. Okay, so this is where statement is there in that. First of all, we write the statement here. What is that statement? Again, they are saying that let px be a polynomial. That means all the variables are in the form of x of degree 1 or more than. Its degree should be a linear polynomial or more than that. It may be quadratic, cubic, whatever. Okay, and let alpha, again alpha has come. And what was that in the previous remainder theorem? That was a real number. Here it also alpha be a real number. Means combination of rational or irrational. It can be any number. And that is if polynomial, if px is divided by x minus alpha, then p alpha is equal to 0. This is called factor theorem. In remainder it was coming r, here it is coming 0. That means there is no remainder. Obviously then this is a factor. If remainder will come, why this will remain a factor? This will something else. So that's why the remainder is coming 0 here. Okay. So now we're going to prove this. This is one of the very important topic of polynomial, and you have to understand this nicely. Okay. So what they are actually saying? They are saying that when px is divided by what? X minus alpha, then obviously some quotient will come. Its quotient is qx and remainder is rx. Understand? Remainder is rx. Here also the same situation. The degree of this rx, that should be less than the degree of x minus alpha. Okay, then what? Then by division algorithm we can say here px is equal to x minus alpha into qx plus rx. Okay, so by remainder theorem that we had studied last class, by remainder theorem, what was that rx? Rx is equal to p alpha. Means if I replace the value of alpha in the polynomial, whatever is coming is my remainder. So in that case, Rx is equal to P alpha. So now this equation will change and this will become Px is equal to x minus alpha into Qx plus, now in place of Rx, what will come? P alpha will come. Okay, so that means now this is my, if this is 0, P alpha becomes 0. That means this all are our factor here. So now see, so what we have written? We have written that Px is equal to x minus alpha into q minus x plus P alpha. Now suppose that if this term becomes 0, so these are the factors. If this term becomes 0, this then these two are the factors of this px. Yes, they are the factors here. So we can write here case 1. If p alpha is equal to 0, automatically px is equal to x minus alpha into qx divided into quotient. Then x minus alpha is a factor. Okay, x minus alpha is a factor here. Suppose I will say no, my x minus alpha is a factor. Now you find the remainder. Suppose that if I say x minus alpha is a factor, we are knowing this, that x minus alpha is a factor, then what will happen? Then px is equal to x minus alpha into qx plus 0. Why? Because this is a factor, so remainder is obviously 0. Okay, it is a factor, then remainder is always 0 here. So we can say here, if x is equal to alpha, then p alpha is equal to alpha minus alpha into q alpha, that is 0. P alpha is equal to 0. So it proved that x minus alpha is a factor. Why? Because p alpha is equal to 0. Okay, remainder is 0, then that is the factor. If it is a factor, then remainder is 0. This is what we had to understand here. Okay, now see, 1-2 examples we'll see on this factor theorem. So let us see. See, basically both are the same, remainder and factor, both are the same. Only one difference is there, in one remainder comes 0, in one remainder doesn't come 0. Suppose that they are saying that, show that so that 2x minus 3 is a factor of x plus 2x cube minus 9x squared plus 12. Okay, that means this is my polynomial px. Okay, so this is my gx, this is my px. So what I have said that our gx should always be 0. That means gx should be equal to 0. That means 2x minus 3 is equal to 0. That means x is equal to 3 by 2. Now this x will go in this equation here. Okay, so what will happen now? This polynomial in x will become polynomial 3 by 2. Okay, that means it is x cube. Okay, x is here, x means what? 3 by 2 only. Okay, then 2x cube means 2 into, what is x here? 3 by 2 whole cube minus 9, what is x square? 3 by 2 whole square plus 12. Okay, then what? Then we just take here, it's 3 by 2 plus 2 into 3 3 is 9 3 is 27 by 8 minus 3 3 is 9 2 2 is 4 plus 12 here. Okay, so now we have to solve this. Okay, so now this will become how much? If I divide this, it will become 3 by 2 plus 27 by 4 minus 81 by 4 plus 12. So this all will come P 3 by 2. We are in the last step here. This will come 2 4 4. LCM is just 4 only. Then this will become 6. This will become 27. This will become minus 81, and this will become plus 48. Okay, so this all will become 0 by 4, that is equal to 0. So proved factor theorem. Yes, it is proved. See, so first of all I will make the factor 0. That factor will give me the value of x. That x I will put in the equation there, and then I will do the simple calculation. So this is what factor theorem. We have learned this. Now example also you understood. So you will take help of this video, and I hope you all will understand this nicely there. Thank you class. Thank you very much.